Hi Precalc, this is the last day of 1.4 notes. We're doing some more things with rational expressions because they're tricky. The first thing that I wanted to show you guys is rationalizing the denominator. Now recall that we had some trouble when it was anything with like a root that wasn't a nice square root, and in this situation we would complete the root. So I would ask myself, the 7th root of x to the 5th times what is going to give me the 7th root of x to the 7th. I'm asking this question expressly because I want whatever I'm multiplying this guy by to give me x to the 7th so that the root and the power cancel. That's my goal. And I know that that will be the 7th root of x squared. So I put it on top and on bottom. And I know this because the 7th root of x to the 5th multiplied by the 7th root of x squared, x to the 5th times x squared is x to the 7th, which is what I want. On top now, I just have 3 7th root of x squared. And then my last step here is the 7th root and the 7th power cancel. And so I have 3 times the 7th root of x squared all over x. So in a situation like this, you're completing the root, or you could think of it as completing the power. Another type of rationalizing the denominator that's tricky is when you see a number plus or minus a root on the bottom. In this case, we're going to use a difference of squares to rationalize. So if I wanted to make 1 plus root 2 times something, and I wanted to turn it into a difference of squares, 1 squared minus root 2 squared. The reason a difference of squares works nicely is because when you use a difference of squares, we're going to square the square root, and that's going to make it go away. Now, to make this be a difference of squares, I need 1 minus root 2. This, by the way, is called the conjugate. It's like the partner of 1 plus root 2. And since I'm multiplying 1 minus root 2 on the bottom, I also have to multiply it on the top. Because something divided by itself is 1, we're just changing the way this fraction looks. We're not actually making it different. And now on the top, I have 3 times 1 is 3. 3 times negative root 2 is negative 3 root 2. So there's my numerator. The bottom is the factored form or difference of squares. When I multiply this out, I'm going to get 1 times 1 is 1 squared. I'll get a minus root 2 and a plus root 2, but those will cancel. And then root 2 times root 2 is root 2 squared. And then from here, I still have 3 minus 3 root 2 on top. However, now on the bottom, I have 1 minus, and root 2 squared is just 2. 1 minus 2 is a negative 1. So I have 3 minus 3 root 2 all over negative 1. And now there's a distributive property for addition for multiplication and one for division. So I can distribute this negative 1. I can essentially divide both pieces by negative 1. So this is negative 3 plus 3 root 2. It changes the signs of both of the things in the numerator. So here, instead of completing the power, you're going to use a difference of squares to rationalize. The next problem is one that you will see quite often in calculus with something called the quotient rule. And it looks crazy. It really does. However, pre-calculus is boot camp, and the whole purpose of pre-calc is to get you ready so that in calculus, when you see craziness like this, you can deal with it. So we are going to work through a couple problems that look kind of crazy like this. Now, in this problem, we've got x plus 1 squared to the half power. Gosh, that's gross. And this is gross. Sometimes, we are going to want to factor first, but sometimes in math, when you see something in parentheses like that that's distracting you, you can use what's called u substitution. So you say u is equal to 1 plus x squared. And now everywhere I see a 1 plus x squared, I'm going to substitute it out. So instead of 1 plus x squared here, I write u, and it's to the half power, minus x squared, and then again here, this is u to the negative half power. And then on the bottom, I have a u. Okay. Now if I want to factor, this looks a little less crazy, not a lot, but a little. If I want to factor this out, I want to take out a common factor. And I know that I need to take out the smallest power, which is this negative half. So I'm going to factor the u to the negative half out. And when I do that, recall that we're subtracting the exponents. So this is going to be minus a half and minus a half. Now, half minus a half is really a half plus a half, so that's going to be u to the first. And a minus half here is really going to change to a positive, so that's going to be u to the 0, or u to the 0 is really 1. And I still have a u down here. Okay. So now, let's see, now that it's multiplication, the connector here is multiplication, I can move this down to the bottom. So I've got u to the first minus x squared. This u to the 0 is really 1, so it's like x squared times 1. And then down on the bottom, I have u to the 1/2 times u. Yeah, this isn't pretty anytime soon, is it? Okay. U to the 1/2 times u, this is really u to the 2/2. So now I've got u to the first minus x squared over u to the 3/2. It's getting a little better. And now I've done pretty much everything I can do with the u's. And now it's going to be time to go back up to what I said u was here. And I'm going to plug that back in here and here. So in this situation, let's see, u was 1 plus x squared. And then I have a minus x squared from the problem. And this u is 1 plus x squared. And then it's to the 3/2 power. And notice on top here the x squareds cancel. And that leaves me with 1 over 1 plus x squared to the 3/2. Or you might see in the back of the book, they might say 1 plus x squared to the negative 3/2. I can't remember what the final answer looks like. Either one would be okay with me. It's still kind of ugly, but it's a lot less ugly than where it started. Notice how much crap we had going on up here. In calculus, this would have been a giant pain in the butt to do anything with. And the problem ends out quite a bit simpler. Still not great, but a lot less work. So you're going to factor. You might want to use this trick of u substitution. And then eventually, you're going to probably reduce or sort of regain some of your, like put together some of your exponents and rewrite. And then either one of these problems would be okay with me. I think actually probably the positive exponent in the denominator would be best. The last thing we have for notes are some common errors that get made all of the time because stupid addition and subtraction don't work the way that you want them to. So here we've got a list of properties that work with multiplication. For instance, a times b squared, you really can distribute the power. Notice though that if you have a plus b squared, we've talked about this before, it's not okay to just distribute the power. So this is a situation that does not work, even though it looks like it should. Again, with multiplication, if you have a times b under a square root, you could break up the roots. However, with stupid addition, it doesn't work. The square root of a squared times b squared. The square root cancels out the squares beautifully with multiplication, so you just get ab. However, we saw the other day in class, oops, and I forgot to write it down, I'll put it down here, that when you have the square root of a squared plus b squared, it does not equal a plus b. That's another situation where most of the time it doesn't work. 1 over a times 1 over b, yep, you can make that 1 over ab, that's great. But with stupid addition, it doesn't work. When we have multiplication and division, we can cancel the a's out over here, and oh look, a times b over a is just equal to b. Isn't that nice? With stupid addition, it doesn't work. A to the negative 1 times b to the negative 1. We could take out the power, essentially, and say that's ab to the negative first. That works beautifully. With addition and subtraction, you're screwed. You can't do that. So the moral of the story here is to beware of pluses and minuses. I like to call them red flags of death because I'm, like drama. And basically, these are always going to kill your problem if you do what's easy. These are the things that are easy to do that are not correct. So you have to make sure to avoid them. This is a big deal in pre-calculus. It's going to come up a lot. And so you've got to really get in the habit of checking your answers all the time. And whenever you see a plus or a minus problem, of being really, really careful that you know what you're doing and that you're not just taking the easy way out. All right, that's it for notes tonight. I will see you in class tomorrow. Have a good one.